Okay, guys, so experimental designs for determining enthalpy. And so I'm going to show you two setups for two different kinds of enthalpy calculations, and we'll be doing both of these laboratories in class. And so I wanted to give you a heads up for them. It is important that you know how to illustrate them because it's likely to be a question that you're going to be asked. And so let's examine the first experiment. So the first one will be to determine the enthalpy of neutralization. And so neutralization would be an acid-base reaction. So for example, HCl plus sodium hydroxide. And that's going to produce salt plus water plus heat, because neutralizations are always exothermic. And so what you want to do is you want to be able to measure this heat, because you would use the delta H or Q, which we've set it to be equal to, equals MC delta T. And so you want to be able to measure that delta H via the mass, the heat capacity, and the delta T in order to solve for the enthalpy of neutralization, which we'll get to the actual way to solve that later. And so the experimental design setup is going to involve some system where we're going to mix the acid and the base together and observe its temperature change. And so that's actually a pretty easy setup. And so what you're going to have is you're going to have some form of insulated container, and that is important. You want it to be insulated, so maybe a styrofoam cup would be a good insulated container. Ideally, you would have an insulated lid as well, because what we want to do is we want all of the heat when we add the two mixtures together. So let's say this is our acid, and we're going to add to it in a second some base. We want all of the heat to remain inside of here. If the heat flows out, then we're losing that heat and we're not capturing it. And so we want all of the heat to stay inside of this system, because we are going to have inside of here a thermometer or a temperature probe, and we want to measure the heat change as we add our base solution. The acid and the base are going to mix, and most of this, remember, most of this container is full of, it's water, because it's aqueous solutions of acids and base. And so the water itself that's in here, that's our surroundings, effectively. That we want those surroundings, we want that water to absorb the heat as the chemicals in the water react together to neutralize each other. And so we're going to measure the temperature change of the water. And so again, if we have our MC delta T, well, we know the C for water. If we know the volumes of these waters, we could calculate the mass using the density of water calculation. And if we know the initial temperatures and the final temperatures with our thermometer, then that will give us the enthalpy change that occurred. And then there's some additional calculations that you have to do to find the enthalpy of neutralization, which we'll get to later. But this is the experimental design setup. That's how you would set up the experiment, using some kind of an insulated container. All right, the enthalpy of combustion experiment is another one. Once again, we want to get the heat. The Q is what we want to get. And so we need to be able to record a delta T as something heats up or cools down. In this case, it's going to heat up because combustion is exothermic. Now, normally, when I have students do this as just a simple lab without me trying to help you do it better, I will use a Coke can. But you don't have to use a Coke can. You can use something else. And Coke cans are usually a little bit concave in the bottom. And you're going to burn something. Okay, so say we're going to burn ethanol. So C2H5OH. Ethanol is a liquid, so that's an easy one to handle. It's going to combine with oxygen. It's going to make carbon dioxide plus water plus heat from the flame. Okay, and so what you'll do here is you'll put some water inside of the can, some quantity of water. You'd measure it out, some quantity of water, and you will put your source of ethanol underneath it, and you'll light that ethanol. Oops, wrong color. you'll light the ethanol, and it's going to burn. Now, as it burns and releases the heat, you want to measure that heat change via a temperature change. As it releases the heat, the reason why I put the can over it and put water in the can is so that the water temperature rises. And once again, we can put a thermometer in there, in that water, and we can measure the change in temperature of the water. As the ethanol gives off the heat, the water absorbs the heat. Heat loss equals heat gained, and we can capture that energy. Now, we still have to do some isolation from the environment, and so you're going to want to insulate this can so that the heat doesn't just flow into the water and then flow out into the room, because that wouldn't be good. We want to capture that heat, so you want to insulate it. You certainly want to insulate the sides. It would be ideal to insulate the top as well, because we can get heat escaping through the top. Now, you don't really want to insulate the bottom, though, because then the flame heat is insulated from the can. So you don't want to insulate the bottom of the can because that prevents the heat from flowing into the can. And so sides and top for sure would be ideal in order to insulate that can. Anything that prevents or that ensures the heat flows into the can is what you want to do here to ensure good data results, or at least the best data results that you can get. And so how you set this up physically, how am I going to get a can over this container of ethanol? And we've got spirit burners. They're just like little tabletop lanterns, if you will. How you suspend the can over it, that's up to you. It's how you want to figure it out. But this is the basic premise of the experiment. You want to capture the heat in a can with water. You know the mass of the water that's in the can. You know the heat capacity of the water. And if you find the initial temperature of the water and the final temperature of the water, you know the delta T of the water, and that's the heat change of the water, which is equivalent to the heat change of the combustion, because heat lost equals heat gained is your basic concept there. So 2 experimental designs. We will be doing both of these at least once in class as an experiment.